The role of unmanned aircraft systems is increasing in military operations around the globe. Operated remotely by a ground control station, UAS may provide the warfighter surveillance, reconnaissance, and attack capabilities, among other functions. The Department of Defense is faced with the challenge of ensuring that communication between services and systems is unhindered and that mission-critical information is delivered. By implementing an open architecture business model to the unmanned aircraft system and ground control station acquisition models, DoD will improve interoperability and, in the process, reduce the amount of redundant development and the associated costs. Currently, most UAS systems are designed, built, and tested from end to end for a specific purpose. Each vehicle requires its own ground control station, with each new system requiring completely new development. Because they are developed independently, there is overlapping functionality that is recreated for each system. This results in a considerable amount of time and money spent designing, developing, and testing capabilities that have already been paid for, making it difficult to upgrade or improve capabilities. The closed nature of the development of each UAS creates proprietary capabilities and a lack of interoperability and commonality between UAS and other systems GCSs, and between the DoD services and their unmanned vehicles. Yet there is a common need to share vehicle data and sensor payload information. DoD will address these issues by implementing an open architecture model to the current UAS and GCS acquisition models to increase commonality across software systems and facilitate component reuse. The first step is to identify common functionality between existing GCSs. These common functions will be organized into service packages, modular software components that integrate into a common framework using standard interfaces. The functional decomposition will be based on which services can be later used to build new GCSs or can be competed against to create best-of-breed solutions. After services have been broken out, essential messages will be evaluated, then added to the appropriate service package as agreed upon by the UAS community. For example, each UAS may transmit information about the vehicle's status. This information consists of messages about vehicle location, engine condition, and so forth. These messages will be added to the Vehicle Status Service, one of many services that will make up the functionality of each GCS in a modular approach to development. A formal process for creating new compliant messages in an XML format has been established so that existing common messages may be reused. This will allow new ones to be auto-generated based on the new standard. Every service will be usable by any UAS or GCS that it is common to, creating commonality across UA systems and DoD services. This allows for rapid integration of new capabilities with established legacy services using new standardized service interfaces. A service repository will then be established to reuse and share common unmanned system capabilities for use in multiple appropriate systems across the Department of Defense. Development of new GCSs will consist of leveraging existing services, supplemented by additional application-specific capabilities as needed. Similarly, systems can be updated or modified by replacing specific services while maintaining proven parts of the system. These capabilities and services are part of an enduring organizational structure that is founded on standards development best practices. The implementation of an open architecture promotes competition and the development of innovative new capabilities by expert industry partners who may otherwise not have been able to participate in the UAS acquisition process. It will greatly reduce both the amount of redundant development and the costs associated with validation, verification, and certification of ground control stations. Ultimately, this will benefit the warfighter by increasing interoperability within the UAS domain across DoD services, resulting in faster transition and adoption of new capabilities.